Okay. I won't talk too much about the first problem. The first problem is basically um, asking you about some outliers. Uh, in Minitab, when you do a regression analysis, the output contains everything about outliers, I think. There's a bunch of like columns, and it tells you which are like outliers. Some of them have an abnormal X range, blah blah blah. And I don't require too much about like question one because we have many repeated work to do. Like I think for question one, you get a whole bunch of data and then they ask you, okay, let's change another set of data and repeat everything again. Um, I don't
So can
think
you
that's too meaningful.
can you
So,
just check that we're running it correctly in Minitab? Like, so I just dropped a link in the chat.
okay.
Is this so? Yeah, because I think that's just like I think we can sort of interpret the data once it gets there, but I want to make sure I'm getting the right thing in Minitab. um,
So,
so like, would
um,
following these steps get us to the right answer? Get us to the right information? Does that make sense? And then we can interpret.
yes. Let me check it.
Yeah, like I agree with Grace because I ran it one way and I don't know if I did the right thing in Minitab to actually get the regression.
Yeah, exactly. Yeah.
I think it's correct. Like in Minitab, when you run a regression analysis, right? Basically, the software already tell you the linear regression equation, and then followed by some analysis, like you have some tables indicating like what is the t-score, what is like r square, those things. And then under those table you have a long column. um, that column indicates some outliers, right? And Minitab has some interpretation. It doesn't have
Oh, I don't know
interpretation,
if
but
I
it
saw the
tells you.
outlier
Yeah,
table.
but it tells you like what number is like outranged, those kind of thing. I don't expect to
Oh, I see what you're saying. Like when we're talking about each of them, you can see which
yeah,
one is
I
really
don't
going in
expect you to
the
go
lab
into
test.
that too much because one of the reason is in the final it's like it's non-open book. You cannot use a computer. So I guess there won't be a question like you have to find all the outliers. You have to interpret all those abnormal predictors. I don't think that that would be the case. So so yes, you just have to like look at those columns and say, okay, what data set might be go wrong, right? There is an abnormal prediction, there is an outlier or something, but don't focus too much on that question. Um, what I'm going to talk about is the F test. Is question number two, the F test, which is very important. And I think like there's 90% chance it would appear in the final. Um, so basically, uh, can you see my picture, the Word document in?
Yes.
Yeah.
Okay, sure, that's good. So basically, I have the formula which is under part B. Like I'm just telling you the answer because this is the last homework, and I don't expect you to like do it by yourself, and because I don't have time to grade it. Um, So part B, the F test, right? The formula is as follows. I think it's also on the slides. It's the SSR divided by K, which is the DF, degrees of freedom, in the numerator. And uh, and then under the denominator is SSE divided by the degrees of freedom in the denominator. So you don't have to look at k and n minus k plus 1. Right? You just remember in the numerator, k, which is on the denominator of the numerator, that is the degrees of freedom in the numerator. And then n minus k plus 1 is the degrees of freedom in the denominator. And how to calculate that? Um, basically, So you already know how to calculate SSR and SSE. Maybe that is given in the exam, but you know how do you find it in the Minitab and how to calculate that. So there is a high chance that those data are given in the exam about SSR and SSE because you cannot calculate manually. And then you have to find the degrees of freedom, which is k and n minus k plus 1. So basically, if I have 5 predictors, right, I have beta 1, beta 2, beta 3, beta 4, beta 5, then k equals 5. So the degrees of freedom in the numerator is how many predictors I have, right, which is when I write the regression equation, the things would be like y equals beta 0 plus beta 1 x1 plus beta 2 x2, etc. You have to know how many predictors you have. So that is k, the degrees of freedom in the numerator. And what is n minus k plus 1? That is the degrees of freedom in the denominator. N is the number of observations you have, right? In the linear regression model, how many observations you have, the total observations, and minus k plus 1. Basically, k is, I just explained what is k. So for example, in the homework assignment, there's 30 observations, I believe, if you look at all those data sets. Oh no, the professor just gave me how many. Okay, so ignore that. Ignore what I said. So n is the total number of observations. Just remember that, how many data points we have. And then k is how many predictors we have. So in part D, there's one question said, okay, we have 40 observations in total, and we have 5 predictors. So what is k? K is just 5. We have 5 predictors. That is the degrees of freedom in the numerator. And what is the degrees of freedom in the denominator? It's 40 minus 5 plus 1, which is 34. So in part D, when I plug in all the numbers to find the F value, I then, again, in an F test, when after I calculate my F value, I should compare that to the F critical value. The way we find the F critical value in the table is we should have 2 degrees of freedom. So here I said FCV parenthesis 534. That is my degrees of freedom first in the numerator and then in the denominator. So I write down 5 and 34. And in the table you can find that critical number. Just like a t-table or like a chi-square table, the way you find the critical number is first you have alpha. Assume it's 5% if it's not strengthened in the question. So you plug in alpha equals 0.05, 5%, and then you have F critical value, which you first find the degrees of freedom in the numerator and then degrees of freedom in the denominator. You can find a critical value, and again, you will reject the null hypothesis when your calculated F is greater than the F critical value. So basically, the F test is to test the overall assumption of this regression analysis. And if you remember the t-test from last week, the t-test is basically a test to find out each beta, if each beta is useful. I don't know if beta 1 is useful, so my null hypothesis is maybe beta 1 equals 0, or maybe I have some doubt for the second predictors. So maybe my null hypothesis for t-test is beta 2 equals 0. But here for the F test, the null hypothesis is about the overall environment of this regression model. And if you look at the homework, maybe I should stop sharing and share again. if you look at this homework document, the question is whether the 5 explanatory variables jointly and significantly affect the response variable. So here the null hypothesis is an overall hypothesis, like all the 5 explanatory variables like beta 1, beta 2, beta 3, beta 4, and beta 5, they are jointly and significantly affect the response variable. If we reject this null hypothesis, again, I can only say, okay, this whole assumption are wrong, right? Those 5 explanatory variables are not jointly and significantly affect the response variable, but I don't know which one is wrong, or which 2, or maybe which 3, right? So that is one of the weak point about the F-test. Again here, so we still have part B and part C. There are some algebra transformation. I will like send out this picture after the office hours. I will send that to the Google Doc that I shared with you. Also look at like part B and part C, because in the exam, maybe because like basically those are 2 questions and that ask you to represent F instead of by using this formula in part B, you will use some other formulas, which is just algebra transformation. But like if you look at the answer for part C, what you're gonna to prove is F equals r squared divided by 1 minus r squared times n minus k plus 1 divided by k. So during the exam, maybe the professor wants to give you SSR and SSE, which will help you to plug in the formula in part B. But instead, maybe the professor gave you r squared or some other variables, which is helpful for you to find the r squared. Then maybe after calculating r squared, you would plug in r squared into the formula in part C in order to find the F score, right? I don't think this formula would be given in the exam, but so because I didn't have a chance to look at the exam, but for those 2 formulas in part B and part C, I recommend you guys to memorize it, because the F-test is very, very important. And in part E, okay.
Can I interrupt you really quickly? Maybe this is a bad assumption on my part, but I kind of assumed because it's now going to be a closed book test, he was going to give us a bunch of these formulas so that we didn't have to memorize them. But do you think that's incorrect? Like, you think he's just going to give us like the tables, like the T distribution?
No, he'll give you the whole formula, but for part B and part C, those formulas are not that obvious, I would say. This is some conclusion, but I would not say it's called a formula. Sometimes it's good to know some conclusion, right? So maybe the professor will just give you the formula in part B and some other formulas, but you can algebraically represent the formula in part B to part C. It's just some algebraic transformation. But in the exam, you have limited time, right? You don't have those time to play with algebra, so it's a good way to memorize just the formula in part C, I would say. It might be helpful.
Well, okay. Yeah, so basically you're just manipulating the formula to different...
Yes.
Gotcha. Okay, cool. Thank you.
And again, one example in part E. In part E, the difference between part D and part E is just instead of 40 observations, I have 400 observations. So what's changed is in the formula of part C, the n minus k plus 1. In part D, I plug in n equals 40, and in part E, instead I will plug in n equals 400. This is one difference. Another difference is about when I find the F critical value, right? I have to find the degrees of freedom in the numerator and degrees of freedom in the denominator. The degrees of freedom in the numerator are just the same, it's 5. Here in part E, you can see my FCV the first number in the parentheses is also 5 because that's the number of predictors we have. We have beta 1 until beta 5. But the degrees of freedom in the denominator is different. Remember, it's the number of observations minus k plus 1. So it's instead of 40 plus 1, 40 minus 1, 5 plus 1, I have 400 minus 5 plus 1. So it's 400 minus 6. So I get 394. And again, in the F table, with alpha equals 5%, and you have 2 degrees of freedom, right? You can find a critical value. Yes, questions?
Can you say that again? So around the degrees of freedom. So what I just heard maybe is that second half of the equation, n minus k plus 1 over k, that's the degrees of freedom on the numerator and the denominator. Is that incorrect? Probably.
So here in part B, you can see the part B. This k is the degrees of freedom in the numerator, which is the first number in my parentheses. And that's the number of predictors I have.
Yep.
So it's 5, right? And n minus k plus 1 is the degrees of freedom in the denominator. And in part D, n equals 40, k equals 5. So it's 40 minus 5 plus 1, which is 34. So that's the degrees of freedom in the denominator.
And another dumb question. So the degrees of freedom, I'm sorry, I'm just degrees of freedom. If we get at, so basically the answer is, if we're asked what is the degrees of freedom, there are two answers. One, there's a numerator degrees of freedom and a denominator degrees of freedom. It's not,
Yes.
there is
yes.
one. Okay.
Yeah, there's 2. But there
there's
won't
2.
be question like that because
Yeah.
the reason you will find degrees of freedom is because you have to find the F critical value. To find F critical value, you should have 2 degrees of freedom instead of 1. Because if you look at the F table, you will see the row and columns are basically all degrees of freedom. So you should allocate 2 degrees of freedom in order to get a F critical value. Another important.
That was helpful, thank you.
Oh yeah. Never mind. Another, I think I have another here. So sometimes the question get more complicated. It's also in your slide, and I think this is maybe the last topic. It's also a F test, but it's like a t-test. You have one sample t-test, and then you have 2 sample t-tests, right? Which is more complicated. Here, right? Instead of asking if my 5 explanatory variables are jointly and significantly affect the response variable, maybe I have 2 models of regression analysis. From the first model, I have 14 predictors. And the second model, I only have 4 predictors. Right, and I want to choose from one. Right, for example, I want to predict a person's height. Right, what are some potential predictors I have? Maybe that person's mother's height, that person's father's height, that person's grandparents' height, maybe that person's weight, right? Maybe that person's age, etc. I can have a lot of predictors, but some of them are kind of efficient, but others are not efficient. So assume I have now. I think of 2 models. The first models have 14 predictors, and the second model have 4 predictors. Which one should I choose? Right? Like there's kind of a trade-off. Because the more predictors I have, there's a higher chance that I get a more accurate regression. but the workload is way higher when my predictors become larger. The workload becomes way higher. So there's kind of a trade-off. Which one should I choose? Here we also do a F-test. And in part B, if you see consider the model with 14 predictors, there's a capital lambda, and the model with the first 4 predictors, I would say it's omega. So here the formula for the test statistics, the formula is as follows. Again, you know how to calculate SSE. So basically the SSE omega and SSE lambda, because I have 2 models. So basically SSE omega is the sum of square of errors for the model with 4 predictors. You should calculate those separately, right? SSE lambda and SSE omega. But that's something you already know how to do it. And in the exam, it's a high chance those data are given. What you want to focus on is also the degrees of freedom. So I said df in the numerator is 14 minus 4. What is 14 minus 4? It's just the model with more predictors minus the model with less predictors. It's just 14 minus 4. That's degrees of freedom within. And again, the SSE omega, I said it's 17.4951. It's probably given because you cannot calculate that manually. You have to use the software to find SSE, right? It's just, I said SSE omega. It's just the same as SSE, but you should understand that as the SSE of the model with 4 predictors, right? You can calculate it. Run a regression in the Minitab, and it's given in the software. The df in the denominator is 30 minus 1 minus 14. 30 is the n, is the number of observations we have. It's just like the simple F-test we just discussed. And then minus 14, the 14 is the number of the higher predictors, right? I have a model with 14 predictors, and then minus 1 is 15. So the way you have to understand is how to calculate the df in the numerator and df in the denominator. Then after you plug in all those numbers to calculate the f, again you have to find the f critical value. Here I assume alpha equals 1%, right? In the f table you have different alpha, and then the way you locate f critical value is, again, you plug in the df in the numerator first and then df in the denominator second. So it's FCV 1015, and then you can locate to f critical value. And in this example, because my calculated f 4.36 is greater than the f critical value, so then I will reject the null hypothesis. And then what does this mean? I reject the null hypothesis. I state that the full model is preferable to the reduced model with only 4 predictors, right? I want to, so the overall question is, I want to compare the 2 models with 14 predictors and 4 predictors. The way my objective is stating that, okay, my previous model is too complicated with 14 predictors. What I think maybe 4 predictors is enough. It's a better way to run this regression model. But I reject the null hypothesis. So that means that the full model, which is 14 predictors, is preferable to the reduced model with 4 predictors.
Hey Victor, I have a question here. So
Yep.
Is this always the case that you find the critical value, and if that is bigger or if that is smaller than your F value, then you take the model with more predictors?
If we reject the hypothesis, right? Because here in order to compare which one is preferable, I have to conduct an F test. My calculated F is 4.36, and the F critical value under the degrees of freedom in the numerator 10, degrees of freedom in denominator 15, is 3.8. Right, my calculated f is greater than the f critical value, so I reject the hypothesis. And the way, and it's always, if I reject the hypothesis, the null hypothesis, I would prefer the model with more predictors.
Okay, thank you. But how do we do we consider ever like the amount of work it is and like the cost of having 14 predictors versus 4? Like I feel like he was talking about that in class where it's like, okay, if 14 predictors are just slightly better, is it actually worth doing all that extra work? Or should we not worry about that?
You don't worry about that. As I said, there's a trade-off because more predictors maybe could mean a more accurate regression model. Maybe that is true. But how could we test it? We use the SF test because we have the SSE in the first model, we have the SSE in the second model, and SSE is one of the results that can say something about the accuracy of my regression analysis. So by conducting an NF test, I know which one is preferable. This is one problem, and another problem is it's true that maybe 14 predictors can lead to a more accurate F-test, but that means a higher workload. So sometimes even though we get more accurate results using a 14 predictors, we would not choose it, right? Because one, there's a higher workload. Two, there's some other problems, including some multicollinearity, those kind of problems, and it's very hard to observe, and that could potentially cause a huge problem in our regression analysis. So basically, the bottom line is in all the theory, in all the statistics theory, and maybe in all the theory in other fields, the more simple it is, the more accurate the theory is. So if we can use 4 predictors to run the regression model fairly accurately, I would not use 14 predictors. So that is the intuition behind that. Hope that answers your question.
Yes, but now I'm kind of more confused because since our F value is higher than the critical value, we rejected the null hypothesis. So we chose the model with 14 predictors. But if we want it to be more simple, like where is the variation? Like where is the line where like, okay, 4 predictors is good enough?
Yeah, because my null hypothesis, why I have my null hypothesis, I think 14 predictors is too much, right? Everybody likes simple things, right? I think 14 predictors is too much. So I came up with a second model with only 4 predictors. That's my null hypothesis. I said 4 predictors are a better model than the 14 predictors. So I conduct an F test. But then after doing the F test, I find out the F critical value is higher than my calculated F is higher than the F critical value. And that means I have to reject my null hypothesis, right? So the way I reject my null hypothesis is I would say, okay, maybe I should stick to the 14 predictor model because just because my 4 predictors maybe are not enough. Maybe I can come up with another model with 6 predictors, 8 predictors, and then I can do an F test again. Maybe I can get a different result, and I said, okay, I would choose a 6 predictors model or 8 predictors model. But the way we compared it is one by one, right? I cannot after doing the F test, I don't know what is the best model. I don't know how many predictors I should choose. But what I know is compared with the 14 predictors model and the 4 predictors model, I would choose the 14 predictors.
Okay, thank you.
Okay, wait, sorry, just to make sure I have this right. So if F calculated is less then F critical we reject.
Yes, it's the same as z-score test, the t-test,
Okay.
or chi-square. Or everything is,
Yeah,
it's basically the
because
same.
in class he was talking about how like F had to be really large, and I guess that is somewhat large, but I just wanted to make sure that that was like the general.
Yeah, it's a general.
Okay.
Sometimes your calculated F is very large, maybe.
Yeah.
And also that caused you to reject the null hypothesis. It's similar.
Yeah.
Sometimes your chi-square are very large. Sometimes your t-statistics are very large. That all leads to a rejection of the null hypothesis.
Gotcha.
So I'm saying it again, sorry. The larger F, if the F is larger than whatever is in the table, we reject the null hypothesis.
Yes.
Thank you.
One thing like I would.
Wait, didn't you just say the opposite of that though?
Yep.
Wait, Grace, can you repeat what you said, please?
Yeah. If F is larger than whatever's in the table, so like, in like E 19.7 is greater than, whatever. Let's see, the 2.29, which is in the table, we reject the null hypothesis and say that it is like significant. Is that correct?
Yes.
Yeah. So bigger F means it's significant and you reject the null hypothesis. Okay.
One thing I want to emphasize is when you calculate the degrees of freedom in the denominator, don't forget that -1. Really have to remember how to calculate the degrees of freedom, the 2 degrees of freedom actually in the F-test. That's very important.
Okay, wait, now I'm confused because I was looking at D in your answer. Right, and there we have the F calculated is 1.7, which is less than F critical from the table, which is 2.53. And then we rejected. So then how come in part E it's different? Do you mind scrolling down a little bit? Yeah. So F calculated is 19.7 and F critical is 2.29. And now our F calculated is greater than F critical, and now we're rejecting?
Yes.
I think
we're rejecting the null hypothesis. Like here is a more simple F-test. We just want to know if the 5 explanatory predictors are useful in this regression analysis. And then I find, okay, my calculated F 19.7 is greater than the F critical value. So I would say the 5 explanatory variables are jointly and significantly affect the response variable. That's how we reject the null hypothesis.
Okay.
I think it's a wording thing.
Yeah, it's a wording thing. It's a wording thing.
But I think, so part D, what you meant was it's not jointly and it's not significantly affecting the response.
Yes, it's a wording thing.
In E, it is jointly and is significantly affecting it.
Yes.
But he just didn't put the not in front of both of them. Does that make sense, Kim?
Yes.
Okay. Yeah.
Thank you.
The most important thing is you calculate the F value and find your F critical value. Okay, so that's basically the last point I want to make, and I will send you I wouldn't send you the answer for question 1, but again, as I said, it's not that important, and what you're gonna do is you run the regression model in the Minitab and you find that column specifying the outliers, the abnormal observation. But it's very important to look at to look at the second question, especially the F-test. And the F-test, and here the more complicated F-test, including like the comparison of 2 models.
I have a question, Victor.
Yep.
So if number 1 isn't that important to know, do we think that maybe we can, instead of doing it for all 4 data sets, just do it for 1? Because if we do it for all 4, that sounds just kind of like a waste of time, and I'd rather be spending my time studying like the F-test and whatnot.
Yep.
So my question is, can we just do it for like the SAT model and not the other 3 data sets? Would you be fine with that?
I'm not too positive. So
Or are you going to help us with, like, when you said you're going to send out the answer for question 1, will that just be in there? Because like if we do it for 1, then we should know how to do it for the rest, right?
so you're talking about the question 1 in this homework?
Yeah, how they basically they want you to repeat it multiple times.
Let's see. Wait a second. I would say, So first, this question 5, if you can see my screen, this question 5 is very, very important.
Yeah, totally. But
Right.
like question 2, 3, and 4 are the same as question 1, but just with different data sets.
Yes. I would say you have to do it, but if you don't do it, I won't get a lot of points deducted. Maybe 5 points, 5 to 10 points for each.
Okay, perfect. Thank you. That's helpful.
Yeah. And it's less likely that those questions appear in the exam. But what you need to keep in mind is just you have to remember what is like the constant variance assumption, what is the normality assumption, how to prove normality, like in the QQ plot, how to check for large Lagrange points, what is large Lagrange points, what is the definition of outliers, what is influential points. Because there's might be one conceptual question in the exam. They just ask you how to deal with those problems or how to find those problems or what's the definition of those problems. So you don't have to find those points in a given data set because that's impossible without a software, but you may get some questions about more conceptually. Yeah.
Victor, are you grading the final?
Yes, I think so.
Okay, thanks.
Like I think I will come to your class on Wednesday and proctoring the exam, and maybe we'll have a happy hour after that.
Yeah, I was just going to say, we'll for sure do a happy hour after, and you definitely should come.
Yeah, definitely.
We will want to, I'm sure we'll all want to drink a lot once this is finally over.
Yeah, so my recommendation for preparing the exam is like I have sent out an announcement saying like you have to focus on all those tests, the Z-score test, the t-test. There's 2 kinds of t-test, the simple t-test and the two sample t-test. And then we have the chi-square test, and we have the regression analysis, which including the t-test that we did last time. There's also a problem about t-test, but like I find like large portion of you guys you didn't do the t-test by yourself, but instead you putting all the data in the Minitab and basically the software generates the t for you. But in the exam, what you're likely to have a question is the professor will give you some parameters like the SSE, the SSR something, and you have to calculate the t by yourself. I think I captured some key formulas in regression analysis, and you can see that for the last office hours. I will again post that formula sheet in the like Google Docs I created, and you have some sense of what's going on. But again, you don't have to memorize all those formulas, but at least you should know like the function of each formula and in which situation you have to apply which formula. That's very important.
And have you talked to him? I know in class he said that he wasn't going to send out the formula sheet before the final. Have you talked to him about that? And do you have any sway on maybe having him send it to us before?
Yeah, I think that's a problem. I will ask the professor for that. I didn't have that formula by now, but I think that's a reasonable request.
Yeah, I think everyone would be very appreciative if we had that. I think it'd be a lot more helpful. Just because,
Yes,
especially like in class, sometimes a lot of the slides have typos. And so I just want to make sure that I know all the right things.
yes, I will talk to the professor.
Thank you. We appreciate it. Any other tips you have? Like, obviously, we'll go through the homework and think through those, but what else would you do if you were us and don't know what?
My way of preparing for the final is look at all the homeworks that I did before. Maybe redo it by myself. Maybe not that hard, but just at least look at all the homeworks and make sure I understand every problem. And the second tips during the exam is just write down as much as possible. There would be a lot of partial credits, and don't focus too much on the calculation part, right? Especially in the probability section, you have like in a binomial model or in the hypergeometric model, you have like n choose k times a lot of combination. Um, you have like something factorials, those kind of calculation process. Don't worry too much about making a calculation error. It's not, I don't have a huge penalty about calculation error. So just make sure you understand the question and you plug in the right formula and write down as much as possible.
Thank you. That's super helpful.
Victor, do you know if all will all of the formulas be on the formula sheet?
I don't know. So that's why I think I would ask professor to maybe give that to you in advance. But I doubt he will make it maybe on next Wednesday. I don't know. So if he had one already, I think he's very happy to share that with you.
Okay. Reason I ask is like some of these formulas are very complicated and some of them are less complicated, obviously, but like it would be helpful to understand like should we be memorizing like the standard deviation formula, the mean formula. Obviously it's something that we should know very, very well. I just don't want to be tripped up on the exam like being asked for a formula that I was like, oh, I would have assumed that this would have been on the sheet.
Yeah, I would say before regression analysis, the formula are not that long. Right, basically you have one or two formula in each probability distribution. In binomial distribution, I guess you only have one formula. In hypergeometric distribution, you maybe have two formulas. You have like exponential and Poisson. I don't know like if professor told you like maybe some of them are not tested, the Poisson distribution, exponential distribution, I'm not sure, but really focus on binomial and hypergeometric distribution. You don't have too much formulas on it. And then the z-score formula, maybe you have only two or three. The t formula, you only have two because there's one sample t-test and two sample t-tests. You have the standard error and the pooled standard error. That's a huge difference. You have two formulas on t-test. On chi-square test, you only have one formula, I guess, but you have to understand how to calculate the expected value. Right? I gave you one table. You should create a second table which indicate the expected number, the expected value, and then you apply that formula to find the chi-square. There exist a lot of formulas in the regression analysis model, and I will send you my capture of all those formulas. I captured that in a Word document. I will put it in the Google Doc. And I would say it should be very helpful if professor can also give all those formula for you in that formula sheet. But what maybe he will not include everything, but instead he made the question, the final question, and then he just put in all the useful formula to answer those questions, and that's enough. But I don't know what's the formatting. I asked him to give you the formula sheet as soon as possible.
Okay, thank you.
Yeah, it sounds like a lot of formulas, but you have already used every one of those formula in your homework. So again, my recommendation is look at every homework problem you did before. If you have some doubts, I don't think you have a lot of doubts on the homework, a lot of problems on the homework. Maybe you just forget them. Take some time and you memorize them again. If you have some problems, you can always watch the YouTube video. I think I have a pretty valid explanation for each question. I didn't tell you the answer, but basically you can follow my step and get the right answer by yourself.
Victor, kind of a specific question. Can you remind me what I'm struggling to understand the difference between leverage points and influential points. So I thought influential points were basically what influence the slope of the regression, but then I don't know what leverage points are. What?
I can't memorize it correctly as well. I think one
Okay.
is like the large leverage points. It's about the X. I'm not too positive, but I think one is about Y and one is about X. Sometimes we have large Y, sometimes we have large X.
Okay.
Yeah, I'm not too positive about that also.
All right. Well, thank you, Victor. This is very helpful. Per usual, you're the best. You're almost done with us. I'll hop off now.
Definitely look at all the homework. Definitely.
Will do.
I felt really like some students asking me for homework solutions. I don't have one, so I asked professor for that, and I'm very surprised that he doesn't have that also. So
I appreciate you sending at least some of them through because I got some wrong on the homeworks, and I was asking everyone. I was like, "Can someone send me the right answers?" I don't even know. So thank you for sending those through. That was really helpful.
Yeah, you use your study group. Like for every homework, there's several students performed very well. So use your study group. I think everybody is happy to help.
Thanks. See you later.
Yeah.
Bye, guys.
Sure.
Thanks, Victor. Appreciate it.
Sure. Good
Thank
luck
you,
for the exam.
Victor. Yeah, you too.